Yes, hi again. This is George Larakis, and today I would like to discuss about the unit circle. The unit circle is a very valuable tool that you will use in math, and it will help you in order not to memorize stuff. As you can understand, the unit circle, it's a circle, as you can see here, that its radius is 1, and in the x-axis we measure the cos, and in the y-axis we measure the sine. Of course, here is the origin 0, this is 1, this is 1, and of course here is the negative -1 and -1. And what this here is useful is for finding the cos and sine of different angles. So let's make it clear what do we mean by that. Let's say that you take this angle here A. So A intersects the circle in the point C. So from the C you bring the projection of this here into the cos axis, and that intersects at A, and you do the same in the sine axis, and that intersects the sine axis on B. So if you measure this thing here, OA, it's equal with the sine of the angle A. This is of course less than 1, and it seems like it's approximately 0.8, let's say. So of course it's positive, and then this thing here, this segment here, the OB, is the cos of A. Which is again in the positive, and it looks like it's approximately 0.4. So that's what we mean that we use the unit circle to measure cos and sine. And let's add one more line, which is this line here, the green line, which is parallel of course with the sine line, and this is the line where you measure the tangent of this angle A. So that means that how you do it, let's say this is the angle A, you extend it after the point C, and in this point here D, where intersects the green line, so we have that, let's say this point here, D, A, B, C, D, E, the ED is equal with the tangent of A. Now, how you can somehow prove this is from the fact that if you take these two triangles, the OAC and the triangle OED, these triangles are similar. Why they are similar? Because they have this angle here A common, and of course this angle here and this here, they are of course equal with 90 degrees angle. Since they have two angles equal, it means that the two triangles are similar. So, and from the now let's take the tangent of A. As we all know, the tangent is equal with the opposite. If you take a triangle, and of course here we take the triangle ODA, so the tangent of this angle here is the AD, which is the opposite, over the adjacent, which is the OA. And now, since we said that these two triangles, they are similar. That means that the the AC over OA can be written also as, sorry, that's AC, sorry. So the AC over OA can be written as ED. I mean, it's the same ratio, ED with OA. Okay, I mean, this ratio here is equal with this ratio because of the similarity of the two triangles that we have here. And now, since the OE is what? Is the radius of the circle. So that means that this here is equal with 1. So that means that you have ED over 1. So, which means that is ED. So that's how you prove that the extension of this line with the intersection of the green line, the tangent line, that gives you the tangent of the angle. Okay, and of course here you can see that let's say if you take an angle, I mean the bigger the angle here, the bigger the tangent, and of course here is the positive. I mean this way is the positive, and this way here is the negative. So that means that the more the bigger the angle, the bigger the tangent, and of course when you reach the point of 90 degrees, because this line here and this line here, they are parallel, that means that the sine of 90 degrees is infinity. The cosine